So, welcome to part 4 in my video series on the preliminary mathematics of cryptology. In this video, I'll be going over Euclid's Extended Algorithm. To help me give you an example of Euclid's Extended Algorithm, I've written up this table that you might recognize from my second video where I went over the greatest common divisor and Euclid's algorithm on how to find the greatest common divisor. The last example I used there, I used the numbers 55 and 34 as value A and value B. And I wrote up the calculation in a slightly different format, this table format that you see over here. The purpose of Euclid's extended algorithm is to find the multiplicative inverse of A modulo B and B modulo A. And to do so, the algorithm introduces these two extra variables, Si and Ti, which we'll be going over the calculations for shortly, which will, in the end, help us satisfy the following equation. If the greatest common divisor of A and B is equal to 1, then we can find two variables S and T to satisfy the equation. 1 is equal to S multiplied by A plus multiplied by B. Satisfying this equation will give us S, which is the multiplicative inverse of A modulo B. So let me write that here. S is equal to multiplicative inverse of A mod B. And T will be equal to multiplicative inverse of B modulo A. If you've watched other videos about Euclid's extended algorithm, you might have stumbled upon a different approach to the algorithm's flow called back substitution. That is not the methodology I'll be covering here today. The outcomes of those two methods, or of these two methods, are the same. It's just a matter of which one you prefer. I prefer this one because it's the one I learned and it's the one that's in the book that I'm following, so that's the one I'll be presenting here today. So let's get started here. As I said, the goal is to calculate S, I, and Ti at every step of the algorithm. And the way we calculate that is we follow a set of rules, and I'm going to write that up below the table here. So let me draw a line. So the rules are as follows. If I is equal to 0, then S is equal to 1, and T is equal to 0. If I is equal to 1, then S is equal to 0 and T is equal to 1. I'm going to move slightly down a bit here, because now comes the fun part. If I is larger than or equal to 2, then the rules are as follows. S I will be equal to S I minus 2 minus quotient I minus 1 multiplied by S I minus 1. I'm going to put line in my number 9 so you can differentiate between 9 and Q. Cool. Then we have Ti. Ti will be equal to, following the same pattern here, Ti minus 2 minus quotient I minus 1 Ti minus 1. I know these long equations here seem very jarring, but it'll be simpler once we get into the calculations. There's just another numbers to keep in your head at the same time. But I'll show you, we'll get through them. So with these rules in mind, we can simply start. And it's at this point that I realize I should have left more space, but let's see if we can get going with this. So I'm going to start with the calculations for S, and I'm going to write them here, I guess. Let me write a line below these things. Okay, so in the very first line here, we have I equal to 0. And per the rules, that means that Si is going to be equal to 1. I'm going to just quickly correct all my 1s here in the quotient so you can see that they're not mistaken for simply lines. And Ti is going to be equal to 0. At the next line, we have I equal to 1. So here we will have Si equal to 0 and Ti equal to 1. And now we get into the fun stuff. So at this step here, we'll have S2 will be equal to S2 minus 2 minus Q2 minus 1 multiplied by S2 minus 1. S2 minus 1. And the numbers then are S2 minus 2 is equal to S0. S0 is equal to 1, so we have 1. Q2 minus 1 is Q1. Q1 was equal to 1, so we'll have minus 1. S2 minus 1 is equal to S1. So that'll be S1, which is equal to 0. So our final result is going to be 1 multiplied by 0. That's 0. 1 minus 0 is equal to 1. So we'll write that over here. S2 is equal to 1. Same thing again, we just go to S3. So at S3 we'll have S3 minus 2 minus Q3 minus 1 multiplied by S3 minus 1. And this will give us S1, which is equal to 0, minus Q3 minus 1, that's 2. So Q2 is equal to 1, multiplied by S3 minus 1, which is S2. We just found S2 to be 1. So here we'll have 1 multiplied by 1, which is equal to 1. And then we'll have 0 minus 1, which is going to be negative 1. So S3 is equal to negative 1. I'm sorry for just writing lines for 1 here, but I'm going to get tired in my hand if I have to write this complicated one. Complicated number one, like here. So let's go to S4. At S4, we have S4 minus 2 minus Q4 minus 1 multiplied by S4 minus 1, which is equal to S4 minus 2 is equal to S2. We found that to be 1. Q4 minus 1 is equal to Q3. Q3 is equal to 1. So that's 1 minus 1 multiplied by S4 minus 1, which is S3. S3 was negative 1. So we'll write that here. Remember, of course, here that multiplication takes precedence over subtraction. So we'll have 1 multiplied by negative 1. That's negative 1. 1 minus negative 1 is equal to 2, because minus and minus becomes plus. So S4 is equal to 2. We'll go to S5. S5 minus 2 minus Q5 minus 1 multiplied by S5 minus 1 is equal to S5 minus 2 is S3. S3 is negative 1. Q5 minus 1 is Q4. Q4 is 1. So that's 1. Multiplied by S5 minus 1, which is 2. Sorry, which is S5 minus 1 is equal to S4. S4 is equal to 2. So here we have 2 multiplied by 1, which is 2. Negative 1 minus 2 is negative 3. So S5 is equal to negative 3. At S6, or I6, sorry, we have S6 is equal to S6 minus 2 minus Q6 minus 1 multiplied by S6 minus 1, and that's equal to S6 minus 2 is equal to S4. S4 is 2. Minus Q6 minus 1. That's Q5. Q5 is equal to 1. You'll notice that almost all of our quotients here is equal to 1, except for the last one, so you'll be seeing a lot of 1s. Then we have S6 minus 1, which is S5. S5 we just calculated to be negative 3. So here we have 1 multiplied by negative 3, that's negative 3. 2 minus negative 3 turns into plus, so that becomes 5. Becomes 2 plus 3. So S6 is equal to 5. At S7 then, we have S7 minus 2 minus Q7 minus 1 multiplied by S7 minus 1. S7 minus 2 is S5. S5 is negative 3. My hand is starting to hurt. Minus Q7 minus 1 is Q6. Q6 is equal to 1. Multiplied by S7 minus 1 is S6. S6 we just calculated to be 5. So that's 5. So here we have 1 multiplied by 5. That's 5. 3 minus 5. Sorry, it's not 3. It's negative 3, of course. 1 multiplied by 5 is 5. Negative 3 minus 5 is equal to negative 8. And here in the final one, we'll have S8 is equal to S8 minus 2 minus Q8 minus 1 multiplied by S8 minus 1, which is equal to S8 minus 2 is equal to S6. We found S6 to be 5 minus Q8 minus 1. That's Q7. Q7 is equal to 1 multiplied by, oh, sorry, let me write negative 8 over here. Sorry, S8 minus 1 is S7. S7 we found to be negative 8. So again, we have 1 multiplied by negative 8. That's negative 8. And we have 5 minus negative 8 turns to plus. So we'll have 5 plus 8. That's 13. So 13 is our S value at the last value of I. And so we can plop that straight into our equation. Let me write that up here, and I'll write it in orange. 1 is equal to blank multiplied by 55 plus blank multiplied by 34. And we just found the first value, S, to be 13. So we plot that into our equation. You can see this is our S value, this is our A value, this is going to be our T value, and over here we'll have our B value. So now we've done all the S values, let's start to calculate the T values. I'm going to move the screen slightly over here because I need more space, and then I'll write a bit smaller maybe. Yeah, I'll do that, and then I'll use the space below the S calculations if I need it. So again, we already found T0 and T1. So let's just get started with T2. So let me draw a line between the two. So let's do a line here. And then we'll have the T values. So we'll have T2 is equal to T2 minus 2 minus Q1, sorry, Q2 minus 1 multiplied by T2 minus 1. Let me write a prettier t for you guys. Multiplied by t2 minus 1. The values then are t2 minus 2 is t0. t0 is equal to 0. q2 minus 1 is q1. q1 is equal to 1, so we'll have 0 minus 1 multiplied by t2 minus 1, which is 1. So the value of t2 is going to be 1 multiplied by 1. That's 1. 0 minus 1 is negative 1. So let's write that over here. Negative 1. Then we have t3. t3 is equal to t3 minus 2 minus q3 minus 1 multiplied by t3 minus 1. t3 minus 2 is t1. t1 is equal to 1. Minus q3 minus 1, which is still 1, multiplied by t3 minus 1 is t2. And we calculated t2 to be negative 1. So we'll now have 1 multiplied by negative 1. 1 minus negative 1 turns to plus, so we'll here have 2. Write that over here. t4 is equal to t4 minus 2 minus q4 minus 1 multiplied by t4 minus 1. t4 minus 2 is equal to t2. t2 we calculated to be negative 1, so let's write that here, negative 1. q4 minus 1 is q3. q3 is still 1, so let's put that there. And then we're going to multiply that by t4 minus 2. That's t3, and t3 we just calculated to be 2. So our equation comes out here 2. 1 multiplied by 2, that's 2. Negative 1 minus 2 is equal to negative 3. So t4 is equal to negative 3. Go to t5. t5 is equal to t5 minus 2 minus q5 minus 1 multiplied by t5 minus 1, which is equal to t5 minus 2 is t3. t3 we calculated to be 2. Minus q5 minus 1, that's q4. q4 is still 1. Multiplied by t5 minus 1. t5 minus 1 is t4, and t4 is negative 3. 1 multiplied by negative 3 is negative 3. 2 minus negative 3 turns to plus, so that's 2 plus 3, that's 5. So t5 is equal to 5. We'll go to t6. t6 minus 2 multiplied by q6 minus 1 multiplied by t6 minus 1. t6 minus 2 is t4. We calculated t4 to be negative 3. q6 minus 1 is q5, so that's still 1. Put that here. And then multiplied by t6 minus 1. That's t5. We just calculated t5 to be 5. So here we again have 1 multiplied by 5, that's 5. Negative 3 minus 5 is equal to negative 8. You may notice a pattern here. t7 is equal to t7 minus 2 multiplied by q7 minus 1. Sorry, I've been writing multiple sign here. It should this should be negative. It's t7 minus 2 minus q7. Actually, just rewrite that whole line. It just looks horrid, actually. We have t7 minus 2 minus q7 minus 1 multiplied by t7 minus 1. And that gives us, sorry for writing this line so awkwardly, but I hope you can still manage to read what it's like, or what it says. So t7 minus 2 is t5. t5 is equal to 5. Minus q7 minus 1 is q6. q6 is still 1. Multiplied by T7 minus 1, that's T6. T6 we just calculated to be equal to -8. So here we have 1 multiplied by -8, that's -8. And then we have 5 minus -8, that turns to plus. So here we have 5 plus 8, that's 13. And now we have the final step, T8. T8 minus 2 minus Q8 minus 1 multiplied by T8 minus 1. T8 minus 2 is T6. T6 is -8. Minus Q8 minus 1 is Q7. Q7 is equal to 1. Multiplied by T8 minus 1, that's T7. T7 we just calculate to be 13. So we'll write 13. 1 multiplied by 13 is 13. -8 minus 13 is equal to -21. And that's our t-value. So let's write that up here in the equation. Now, one final step here before we're completely done. I showed you in my very first video that we're calculating with a set of integers, namely c. But when we're trying to find the multiplicative inverse, we must find that value within the subset of integers cm, where m is the modulo value. And that set cm goes from 0 till m minus 1. And that poses a problem because the t-value that we found is -21, and which we put into the equation up here is our multiplicative inverse of b, modulo a, meaning a is our m value. So the set cm is m equal to 55, which means the set is from 0 until 54. Now, of course, it doesn't matter if it's 54 or 55 because -21 is less than 0 and as such is not within the set. But the way we get around that is we can use our modulo arithmetic and simply add 55 to -21. And -21 plus 55 is equal to 34. So it turns out that 34 is the multiplicative inverse of 34 modulo a. So to sum up, and just as a reminder, the multiplicative inverse is the value that we multiply onto a value modulo m such that the result is 1. So in our instance, that means that we have to take s multiplied by a mod b, and that should be equal to 1. And we should take t multiplied by b modulo a, and that should be equal to 1. And in our example, the values that we found here, and if we put into our equation, is 13 multiplied by 55 modulo 34 and -21 which is congruent to 34 multiplied by 34 modulo 55 is equal to 1. So just before we do a recap of what we've done in this video, I want to show you that the values that we found are correct. So let's open up a Python window, size it a bit. Let's start by initializing some variables. So first we have a equals to 55, b is equal to 34, s is equal to 13, and t is equal to -21. So first I want to show you that we found the correct multiplicative inverse of a modulo b. So we take s, multiplied by a modulo b, and this should be equal to 1, and it is. Then to show you that we found the multiplicative inverse of b modulo a, we'll take t multiplied by b modulo a, should also be equal to 1, which it is. And finally, I want to show you that we satisfied the overall equation of the greatest common divisor being equal to 1, being equal to s multiplied by a plus t multiplied by b. So if we take s multiplied by a plus t multiplied by b, then this should also be equal to 1, which it is. Now, I also just briefly want to show you that our conversion of the t-value from being negative to positive is correct. Because remember, the t-value needs to be positive when we use it for actual encryption. So our trick was that we took t and then we added a onto it. So we assigned t to t plus a, and this should now be 34, which it is. And then if we take t multiplied by b modulo a, this will still be equal to 1 because negative 21 and 34 are congruent. But if we fill it into our overall equation, so if we take s multiplied by a plus t multiplied by b, then this will now be a much larger positive value, 1871, which makes a lot of sense, of course, because if you take two sets of positive values, multiply those, take the product of those two and add them together, then of course that value is going to be positive. So yeah, this is just to show, this is, should we say, the proof that our numbers are correct and that the methodology works. To cap off the video, I want to do a quick summary of all we've done because I think there was a lot of information to take in. We started out by having two values, 55 and 34, of which we had the greatest common divisor equal to 1 from a previous video. Because the greatest common divisor of 55 and 34 is equal to 1, we know that there exists a multiplicative inverse of a modulo b and b modulo a. Euclid's extended algorithm tells us that we can find those two values to satisfy the equation the greatest common divisor of a and b is equal to 1, which is equal to s multiplied by a plus t multiplied by b. The way to find the value of these two variables is to calculate s and t at each step of the greatest common divisor calculation. And the way to calculate those two values is by a set of rules, which is defined down here, which yielded a lot of values for s and t. The final value of s, 13, and of t, negative 21, we took and put into our equation up here. And then we realized that the t value was not within the set of Cm, because the set of Cm, which in the instance of t has an m value of 55, was not in the set because the set only contains positive values. So to get around that, we added our m value, which is the a value in this example, onto t to arrive at the value of 34. Finally, we then looked at the initial goal, which was to figure out if s multiplied by a modulo b was equal to 1, and if t multiplied by b modulo a was equal to 1. And we plopped in the numbers into the equations down here to show, or not to show, but we wrote up that 13 multiplied by 55 modulo 34 should be equal to 1. Negative 21, which is congruent to 34 multiplied by 34 modulo 55 is equal to 1. And then we showed with the Python window that we found the correct values. This has been my video on Euclid's Extended Algorithm. I know it was very long. I hope it was helpful. When I first had this material, I thought it was really, really complicated, and without a step-by-step walkthrough of what happens in the algorithm, it was, to me at least, impossible to follow in class. So I had to search elsewhere for information, and I hope now that I've contributed to the understanding of the curriculum. Thank you so much for watching. Good luck out there, I guess. Take care.